Hi, my name is Craig Loewen. I am a product owner at Microsoft, and I work on the Windows Subsystem for Linux. And I'm joined today by special guest, Oliver.
Thanks, Craig. Hi, everyone. I'm Oliver. I'm the product manager for Ubuntu on WSL and Ubuntu Desktop at Canonical. Thanks for having me.
Very good to have you here because today is a very exciting day because we're announcing that systemd support is coming to the Windows Subsystem for Linux. And this is something that we've partnered on for testing and early access, so very excited to have you here. What does systemd support actually mean, and what is systemd? Well, systemd is a software suite that has basic Linux building blocks for interacting with Linux system. It allows you to manage your system and services of what is running inside of it. And so a lot of tools depend on systemd. Things like Snap, which is an Ubuntu tool that allows you to easily install software, or tools like micro.ks, which allow you to run a local Kubernetes cluster on your machine. We have some demos for that today, and we'll jump over to my machine and take a look at this first one. And so what we have is essentially I'm on my desktop. This is a Windows terminal window, and I have a project here that's using a micro.ks demo. So we're going to show you what micro.ks is and how you can interact with it. I have this open up here in VS Code, and I have it running as a web server. And so this web server looks like this. All it is it has all of my different websites here. So these are actual websites that are running in a local cluster on my machine. And I've simulated these computers coming in and trying to buy something on the website. And so they come in randomly about every 10,000 seconds. And so let's go and change this. Using micro.ks, I can change how many websites I have. And so I can go ahead and scale it up or down. And so here, I've changed the scale to 1. And so that means I only have one website running right now. And you can see I have lots of computers requesting to buy stuff off my website.com. And when they wait too long, because the server can only process so many at a time, they fail. So you can see them turning yellow and leaving the site, not completing their purchase, which is not good for me or my business. And so what I want to be able to do is scale this up and say, hey, give me 10 more of my websites so I can adjust to this demand. And so what's great about a tool like micro.ks is I can just run this command at scale, essentially. And now it will create this website. So it's creating all of these containers that host my website. It's creating multiple of them, all locally on my machine. And now any new web server, web client that comes in is routed appropriately to one of these websites. And so all of these requests succeed. What's really cool here is that this is actually a pretty challenging thing to do. You have a lot of different system services and processes that all need to be managed. And that's why this depends on systemd, because systemd is working behind the scenes to make sure that all the processes are running correctly and being utilized appropriately. So that's just one demo. We're going to hop over to Oliver's machine to take a look at how you can use Snap as well to install some software.
Fantastic. Thanks, Craig. So yes, snaps are a fantastic sort of packaging system that basically delivers sandboxed applications that include all of their dependencies. And they run on any system that has systemd. And that makes it really easy to get up and running with certain complex applications without having to worry about dependency management or compatibility. So I've actually got a number of snaps installed on my WSL instance already. I've got Beekeeper Studio for looking at some databases. I've got Firefox, but I've also got a Nextcloud instance here, which is a kind of self-hosted file server that's very popular on Ubuntu Desktop. And so if I want to take a look at that, I can see that under my services, there's actually a number of different systems running as part of that Nextcloud application. So I've got an Apache web server, I've got a MySQL database, and it's really easy for me to go to my local host here and see everything up and running in my native Windows browser. And so that's something that that is really quick to set up and really sort of demonstrates all the different things that that snaps can do on systemd. But if you're thinking about more in terms of development, then I think one of the most interesting things is to look at LXD. Now, LXD is a virtualization system that allows you to manage containers on your machine. So I actually have a number of Lexi projects actually set up at the moment to organize my containers and my workflow. So for example, I have a project here that I'm currently in called Client Website. So I'm building a website for someone, maybe for Craig actually. And I've also got a home lab where I'm setting up, I've got another Nextcloud there, maybe have a AdGuard or Pi-hole or something like that running. So in my client website, which is where I currently am, I've actually got two containers. One is a database server and one is a web server. And these are both running on Ubuntu 22.04 server images, but there's a whole range of images you can choose from when using Lexi. So with Lexi, I can go into one of these, my DB server, and interact with it as a root user. And then if I run systemctl status MySQL, you can actually see that I've got a MySQL database up and running here. With regards to my web server, I've actually got a very basic, out-of-the-box Apache web server running. And what I can actually do is, because I've got those IP addresses for my container, is I can run Firefox inside WSL. And you can actually see that I've got my Apache web server up here and visible. And because the Lexi containers have static IPs, it's very easy for me to hop around all of the different things that I have running in my various containers at any time.
Wow. And so all of these workflows that we just demoed wouldn't be possible to do without systemd support, because they all depend on the systemd tools to basically give the functionality they showed. So how did we actually do this behind the scenes? At a high level, systemd needs to be started when you start your system, and WSL has its own custom initialization process. We essentially just added systemd as part of our initialization process. So when you start WSL, we start a VM for you, we load your distro, and then we start systemd inside of that distro. Once you actually start a Linux process, we kick off systemd, wait for it to load, and then start everything from there. So everything should just work as intended. If you want to get access to this, we'll be rolling this out to insiders first and then as an opt-in. So you just need to make sure you're on the right version of WSL in the Microsoft Store. And you need to make sure that you have added the right configuration to /etc/wsl.conf. If you want to learn more about how to get started with this, you can go to aka.ms/wslsystemd. And if you want to learn more, you can always follow me on Twitter at Craig A. Loewen. And for Oliver,
you can find me on the Ubuntu discourse under local optimum.
Awesome. Thank you so much for joining us today, and have a great day.